Next thing is they can ask you what is the cardiac axis calculation. Either the cardiac axis they will ask, or what is their interpretation with respect to the axis. If you know the axis calculation, then interpretation is pretty simple. There are several methods to calculate cardiac axis, but we'll choose one method whichever is easier for us. So coming to axis. Axis, what does the term axis means? Axis means it is telling me the direction of the heart. So what is the major direction of the heart? It is towards the left foot. That is the direction of that normal person, because the left ventricle is dominant. But if the right ventricle is hypertrophied, what will happen? Most of our instantaneous vectors will go towards it, and final meal vector can go towards it. So if the axis is shifted, what I can tell? If the axis is shifted to the right, it means that the right heart's potential is more. What could be the reason? There could be a right ventricular hypertrophy. So whenever there is a right ventricular hypertrophy, it is going to shift the axis reverse. If it is shifting more towards the left, what does it mean? It means that the left axis deviation or a left ventricular hypertrophy can be there. Sometimes it can shift it to reverse also. I'll tell you what is the term used for that in a while. Just for the normal cardiac axis, what is the degrees? If the heart lies in this position, we call it as a normal cardiac axis. So the normal cardiac axis is between minus 30 degree to minus 100 degree. So this is the direction of the heart normally. So it is between these ranges, minus 30 to 100 degrees. Some book says 90 also, both of it is correct. So coming to this axis. So with axis, how will you calculate the axis? We have to take, now we are taking the pictures of heart in different directions. So once I compare the pictures of various images, I will try to understand in which direction the amplitude is maximum. Whatever direction the amplitude is maximum, that will give me the heart's direction. Now let's see. For this calculation, we will take two leads, whichever is simplest to calculate. Then if needed, we will add one more lead. So first thing is, what is the direction of lead 1? The lead 1 is going like this in this axis. So it is in the 0 degree. So the lead 1 is in the 0 degree. And one more lead we will take, which is in the 90 degree, so that it becomes easy for us to calculate. We can take any two leads. It's not mandatory to take these two leads, but these two leads are simplest form to calculate. And what is the lead which is going through the foot? It is AVF, augmented lead VF. The AVF is in the 90 degree mark. So this becomes, the shaded area becomes the normal axis. Whenever it is deviated more towards the left, it is called as LAD, which is left axis deviation. Then whenever it is shifted towards the right, it is called as, see here till 100 I have marked it, it is normal axis. If it is shifted towards the right, it is called as right axis deviation. Then whenever the axis is shifted extremely towards the opposite direction, normal towards the axis direction is shifted towards extreme, it is called as extreme axis deviation. Extreme axis deviation. This extreme axis deviation has also one more beautiful name. It is called as southwest axis. It is called as southwest axis. So this is the axis of all the all normal and abnormal axis. Now we are going to take these two leads, like lead 1 and lead AVF, and see their potentials and calculate the axis. This method is called as Venn diagram method. I'll explain you it. The explanation might be a little longer, but the end result will be very easy. You just can calculate the axis in just 2 seconds. I'll guarantee you, you can calculate in just 2 seconds. So coming to this, first we have to understand. So how to do it? So any lead you take, that is the lead 1 we have taken. In lead 1, this half will be positive. If the lead 1's potential is recorded positive, then it means that it is located somewhere here. If the leads 1 potential is negative, it means that the waves are going somewhere this direction. So for any lead we take, we have to draw a perpendicular first. For example, this is the lead 1, and this blue line, whichever we have drawn here, that is the perpendicular for it. So if the positive is showing in a lead 1, then it falls in somewhere this region where we have highlighted with a highlighter, this yellow region. In a similar manner, the AVF is like this. So when you draw a perpendicular, so this is the perpendicular, this is the AVF lead, and perpendicular to it, we have drawn one blue line. Whenever it is showing a positive direction, I will shade off this area, then below area. So this will be our positive side for the AVF lead, and the other side will be the negative side for the AVF. So I'll tell you one example, then we have to see the overlapping area, and finally we have to calculate the axis. It means that we are taking help of two different pictures of the heart and trying combining them, and whichever is the final outcome, that will be taken as the direction of the heart. So let's try with an example. So the simplest possibility, so there can be four possibilities only. So for example, I read an ECG, and that in that ECG the lead one is showing a positive deflection like this. So we should average out it here 1, 2, 3, 4, 5, 6. Suppose 6 leads are there, 6 positive is there, and 2 negative is there. Still it is positive because plus 6 minus 2 is equal to plus 4 millivolts. So we have to average out because some of the waves will go negative also. Some of the waves will go negative also, like the Q wave and S wave. So we have to see the entire deflection. Entire deflection is positive. So if the lead one is showing a positive deflection like this, and lead AVF is also showing a positive deflection like this. So according to our Venn diagram method, first I will tell you for lead 1, what I should do. For lead 1, which is the positive direction, I should shade this area. Now coming to lead AVF, for example, now we are taking lead AVF. Lead AVF also in our example, it is positive. So what should I do? For lead AVF, it is the lead is going like this, but our perpendicular is like this. Lead AVF, what is the positive area? This is the positive area. Now compare these two diagrams and tell me which is the overlapping area. It's pretty simple. We have done this in our mathematics also. So this region is our overlapping area. So where should I change? If the lead 1 is positive and lead AVF is also positive, then we should shade this area, which is the common area for both of them. If both the leads are positive, then this area will be shaded. Where it is lying, if both the leads are positive, then it is going to be a normal axis. Understand it? The final end result is very simple. Normal axis. Now let's take an extreme condition. Both the leads are negative. Both the leads are negative. So lead 1 is showing a negative and lead AVF is also showing a negative. Lead A1's lead 1's negative will be this direction here and the below also. Lead AVF's negative will be this area, the above area. We should check for the common area. Which is the common area? The common area will be this one. The common area will be this one. If both are negative, this is the common area. What is this axis deviation? It is our extreme axis deviation. Extreme axis deviation. It's pretty simple. Now let's go into the third condition. When one, now we have seen both positive and both negative. When both are positive, it is a normal axis. When both are negative, it is an extreme axis deviation. Now coming to the third scenario, which is the lead 1 is negative and lead AVF is positive. So whenever the lead 1 is negative and lead AVF is positive, the common area shaded will be here. The common area shaded will be here. Let's do the simple again one more time, so that it becomes easier. So this is lead 1. What is the negative? Lead 1, we said it is negative. So which area will be shaded? This area will be shaded. And lead AVF is positive. Lead AVF is positive. So which area should be shaded? The below one should be shaded. What is the common region? The common region is here, as you can see it from the diagram. So what is this axis deviation? It is our right axis deviation. It is our right axis deviation. Coming to the fourth scenario, where the lead 1 is negative and lead AVF is positive. So the common shaded area will be here. You can do your maths by yourself. The common area shaded will be here. This area, what do you tell me? It is normal or abnormal? It can be normal or a left axis deviation also, because this area till minus 30 degree. What is it? Till minus 30, it is a till minus, just a minute, till minus 30 degrees, it is a normal axis. So whenever this combination comes, it can be a normal axis also. And this area where I am putting the dots, it is a left axis deviation. Left axis deviation. So both of it can be there. It can be a normal axis also and left axis also. Now what we have to do? We have to take help of one more lead. The another lead that we are going to take is lead 2, because lead 2 is in this direction. And whenever you do a perpendicular for lead 2, now lead 2 alone I will tell you, this is the lead 2 and perpendiculars we draw it with blue. So if the lead 2 positive will be what? Positive will be here and the negative will be in this area. So seeing this diagram, you are going to tell me now, So if the lead, now we have considered two leads. Lead 1 IC, it is negative. Lead AVF IC, it is positive. Now we will take the lead 2. If lead 2 is positive, what does it mean? It will form a combination here. So it will form a combination here. This is the shaded area and it will be a normal axis. So in this situation, what we have to do, it can be a normal or left axis deviation. Now I am going to see the lead 2 also. In lead 2, if I get a positive wave, it is pretty simple. It is a normal axis. Now we are just taking help of one more lead. That's it. Now if it is negative, what we are going to do, it is a left axis deviation. If you don't remember any of it, it's completely fine. But the end point we have to remember. The summary, that is very, very important. Let's summarize all of it. It's pretty simple now. When both the leads are positive, for example, in this scenario, there is a positive deflection in lead 1 and positive deflection in lead AVF. When both the leads are positive, what is our axis? It is normal axis. Pretty simple. When both the leads are negative, what is our axis? When both the leads are negative, we saw it is an extreme axis deviation. When lead 1 is positive and lead AVF is negative, what does it mean? What does it look like? It likes two people are departing from each other. They are leaving away. This is a mnemonic. It looks like leaving away. And in this is the one combination where we saw either it could be a normal axis or it could be a left axis deviation. So that is why this mnemonic came, leaving away for left axis deviation. When they are leaving away, it is a left axis deviation. But we have to confirm it with the lead 2. So when this leaving away pattern is seen, what we have to do? I should go and look for lead 2. Once I look lead 2 and lead 2 is giving me a positive deflection, so then it will be a normal axis, and lead 2 is giving me a negative deflection, then we have a left axis deviation. When both are approaching each other, then they are right. They are going together. So it is called as right axis deviation. So if you remember this summary, that is more than sufficient for us to put all the axis MCQs. All the axis MCQs can be done with the help of this. Here what we are doing, here both the leads positive, it is a normal axis. Both the leads negative, it is extreme axis deviation. They are leaving away, it could be a normal axis also and left axis deviation. Leaving away, don't try directly write left axis deviation. It could be a normal axis also. We just have to consider the lead 2. Then it is positive, then it is a normal axis. If it is negative, then it is a left axis deviation. They are trying and coming closer, it is they are in right position, so they are right axis deviation. If the lead AVF is not given, you can go for the lead 3 also. Lead 3 is a little deviated from AVF, but still you will get the same results like this. Only limb leads are given. Sometimes they will show you an image where only the limb leads are given. I can take lead 1, lead 2, lead 3 only. I don't have the other leads at all. So what, instead of this AVF, we can replace it with the lead 3, because lead 3's direction is somewhere, it is going like this. Where it was AVF was going like this. It is a little away from it, but still all the results will be very similar to that of the lead AVF.